Hey guys, Dr. Brown here with Kubo Math. Have you ever asked yourself when you're using some formula, where did they get that? Well, that's what we're going to look at tonight. We're going to take the derivative of tangent x. Now we know derivative of tangent is secant squared x. Okay, I get that. Well, where did they get that? Where did it come from? So we're going to use the limit formula and we're going to calculate and see if we can come up with secant squared x. So let's get after it. So we're taking the derivative of tangent x and we're utilizing the limit of, as h approaches 0 of f of x plus h minus f of x over h. So now we just have to plug in tangent x and crank it out. Alright, so we have tangent x plus h minus tangent x over h. Now and I've written all these limits down just so I don't have to keep writing it, take up your time. Okay, so now the limit as h approaches 0. I need to break out this double angle formula here. So there's one that says tangent of x plus h could be written as tangent x plus tangent h over, I'm going to bring this h right over here, times one, or divided by 1 minus tangent x tangent h. Now all of that is just this tangent x plus h. We still have minus tangent x out there and it's still over h. Okay, well now let's get a common denominator. So we know if we were to multiply 1 minus tangent x times tangent h over 1 minus tangent x tangent h, then we just simply multiplied this by 1. So just imagine we've done that. So now we have h 1 minus tangent x tangent h okay, and all of that's times divided into tangent x plus tangent h minus, now I should write this down up here I guess, just so you can see what I'm doing. Okay, so now then I have this negative tangent x times 1, so that gives me negative tangent x. And now negative tangent x times negative tangent x tangent h. So it gives me a positive tangent squared x tangent h. Okay, and all of that's still over that function there. Now then, what can we do? Well, we've got a tangent x minus tangent x. Those cancel. And I'm left with the limit as h approaches 0 of tangent h plus tangent squared x tangent h all over h and 1 minus tangent x, sorry, then tangent h. All right. Now then, let's take and just transfer that up here so we can see what we're working with. We still have the limit as h approaches 0. And I'll try to write a little bit neater for you. Tangent h plus tangent squared x tangent h over h times 1 minus tangent x tangent h. Okay, you can see in this one here I have a tangent h here and a tangent h there. I could just factor one of those out. So let's do that. I have tangent, the limit as h approaches 0 of tangent h times 1 plus tangent squared x. Okay, so if I multiply tangent h times 1, I get this term. Tangent h times tangent squared x, I get that term. Okay, so we're good there. Divided by h, 1 minus tangent x tangent h. Okay. Now then, I'm going to take this. There's two things we can see here we can do. I could take this tangent h over h and pull it out as a limit. And actually, I'm going to take this and change it to sine over cosine. So let me take sine h over h. I'm going to pull that out to itself and multiply that by the limit as h approaches 0 of 1 plus tangent squared x, which is secant squared x, divided by this term, 1 minus tangent x tangent h. I know what you're thinking. You think I forgot that cosine term, but I did not. I'm going to put it here. Cosine h. So this, we took tangent, changed it into sine over cosine h. But I pulled this h over here, so now the h is with the sine. And change 1 plus tangent squared x to secant squared x. I still have this denominator, and this was the cosine. It went underneath that sine. It came from tangent. Okay. This is not so obvious, but this is one of these things you just need to remember. When you see that, a limit as h approaches 0 of sine h over h or sine x over x, that's 1. If you put your calculator on radians and you said h approaches 0 and let 0 be 1 times 10 to the minus 6, what you'll find is sine of 1 times 10 to the minus 6 is 1 times 10 to the minus 6. So if you take 1 times 10 to the minus 6 divided by 1 times 10 to the minus 6, you get 1. So I would encourage you to try that. So, but this term goes to 1. And now, so 1 times this limit as h approaches 0. Okay, as h approaches 0, cosine of 0, that's 1. As tangent h, as h approaches 0, it's the same scenario as you had here. If you plug in 1 times 10 to the minus 6, you'll get 0. Well, when you get 0, those two terms are wiped out. So the limit as h approaches 0 is secant squared x over all these things equals secant squared x over 1, which is, so now that derivative with respect to x of tangent x equals secant squared x. And that, my friend, is the derivative of tangent x, and how you find that it does equal secant x, secant squared x. Okay, why are we doing this? We're crazy, all right? No, we're trying to build a better tomorrow and do that through math, okay? And you'll see a little saying down at the bottom. We don't rise to the occasion, rather we sink to our level of preparation. So why are we doing this? We're actually preparing, we're studying. That's how we're getting prepared so that when the opportunities present themselves, we're ready for them. Okay, that's all for now. Keep studying and we'll talk to you next time. Thanks.